So one of the things that we were actually talking about in the last lesson, but we weren't actually calling it this, are actually domain, domain, and range. So we were talking about input and output values. Well, the domain is the input value. The domain are the set of input values. Sorry, the domain is the set of input values. Or you can consider them the x coordinates of the ordered pair. So if I were to write this out, we could have x naught, x sub 1, x sub 2, x sub 3, and so on. And then for our range is the set of output values, or the y coordinates. So these all correspond: y naught, y1, y2, y3. And the relation is the correlation between one domain, one individual x coordinate and one y coordinate. So that relationship is actually the relation, what we were talking about in the last lesson. All right. So domain and range is something that is really going to continue to come back in the near future in algebra. And it's something to really keep in mind. So if the domain is the set of x coordinates, then from the previous lesson with the skydiver, we could call the domain as the set, and you can start writing a set using this notation right here. This indicates the beginning of a set, as the time, all of the time inputs that we were actually using for the problem. So those times were 0, 4, 8, 12, and 16 seconds. All these were measured in seconds. And then we can close our set like so. And then our range is indicated by the heights that we use that corresponded with these domain values. And we're going to start a set, and this is going to be 10,000, 9,744, 8,976, 7,696, and 5,904, closed set. So these are actually our output values, which we were calling them in the last lesson, but actually our range, or the set of y coordinates. So that's very important to understanding a function. And a function, which we're now going to begin discussing, a function is a relation in which each element of the domain corresponds with exactly one element of the range. Okay, so let's break that down. A function is a relation. It is a relation, what we were talking about before, in which where each element of the domain corresponds with exactly, that's important, one element of the range. All right. Now, this is very important in the sense of I was actually explaining in the last lesson about how one member of the domain can actually correspond to multiple values in the range. Well, that can happen, but in that case, then what those inputs and outputs are describing on a graph, if we were to graph those inputs and outputs, it wouldn't describe a function, because a function is a relation where each element of the domain corresponds with exactly one element of the range. Exactly one element of the range. So if one element of the domain corresponded with two elements of the range, then we would not have a function. Okay. So let's continue over here. All right, so let's list a domain and range and see if we can identify a function. So if we were given a domain, let's say -3, 0, 4, and then we're given a range, -2, 1, and 7, and then we're told that -3 corresponds with -2, 0 corresponds with 7, and 4 corresponds with 1. Okay, so is this relation a function? Well, let's go back to our definition of a function. If a function is a relation where each element of the domain corresponds with exactly one element of the range, well, is that accurate here? Well, I'd say yes, it is. One element of the domain is corresponding with exactly one element of the range in each point here. So the the -3 corresponds with the -2, the 0 corresponds with just the 7, the 4 corresponds with just the 1. So this relation is a function. All right. How about this? What if we were given a set? So I'm starting a set here, and we're given some ordered pairs. Here, if you can remember the name of this over here, it's a mapping diagram, correct? So in this case, we're actually looking at in this case, we're actually looking at ordered pairs. So our first ordered pair is 4, -1. And then we're given 8, 6. We're given 1, -1. 6, 6. And 4, 1. And then we're going to close the set here. All right. So if each x coordinate must correspond to only one y coordinate, is that the case here? Well, I can see here that we do have an x coordinate that is showing up twice in these ordered pairs. We have a 4 here and we have a 4 here. And the 4 here in the x coordinate is corresponding to a -1 in the y, and the 4 here is corresponding to a +1 in the y. So that tells me that each x coordinate does not correspond to only one y coordinate, and this relation is not a function. All right, we're going to leave that there, and then we're going to pick this up at the next lesson.